Section 2.5, Multiplying Fractions. There's basically two steps to multiply fractions. The first step, and a very important step, is to remove common factors from the numerator and denominator first. We talked about how to remove common factors in the previous section. Once you've removed common factors from the numerators and denominators of the fractions being multiplied, you then can multiply the numerators and multiply the denominators straight across. So for example, 2/3 times 1/6. The first step is to remove common factors. So I'll start here with the 2. The only factor of 2 is itself. So I go to the denominator. Well, 2 cannot divide 3 evenly, but 2 can divide 6 evenly. So that means I can go ahead and divide 2 and 6 by its common factor of 2. So you typically will cross out the old number and do the division. 2 divided by 2 would yield a 1, and you write it above it, and 6 divided by 2 would yield a 3. There's no other common factors since we have just 1's on top. Nothing's going to reduce. And so now we can go ahead and multiply straight across. Once we've crossed out a number and replaced it with a reduced number, that is now, in this case, the new numerator. So 1 times 1 is 1, and 3 times 3 is 9. So the result is 1/9. It may not be uncommon when you multiply that there are no common factors. So in this particular problem, notice that you have the 3 and you look in the denominator. Well, 3 is not a factor of 5, 3 is not a factor of 7. Here you have a 4. 4 has a factor of 4 and 2. Well, 5 does not have a factor of 4 or 2, nor does 7. So there is no common factors. So in this case, you just go to step 2 and do the multiplication. 3 times 4 is 12. 5 times 7 is 35. If you cannot find a common factor before multiplying, there's no need to try to reduce your answer. It will be in lowest form. You may have multiple cancellations. For example, I have 6. Well, the common factors of 6 are 6, 3, and 2. So I go to the denominator, and 25 does not have a 2, a 3, or a 6 as a factor. But 42 does have 6 as a factor, and I want to try to get the biggest factor possible. So 6 can divide itself once. 42 divided by 6 is a 7. Now I move to the 5. Well, the only factor of 5 is going to be 5. Of course, 25 can be divided by 5. So I will remove the factor of 5 from both of these. 25 divided by 5 is 5, and 5 divided by 5 is 1. I now can multiply the new numerators and the new denominators. 1 times 1 is 1. 5 times 7 is 35. A whole number is also considered a fraction. So if you have a situation like this where one of the numbers is a whole number by definition is the number over 1. So view this as really 9/1 times 2/3. And then you proceed as before. 9 has a factor of 9 and 3. So we go to the denominator. Here's a 3, so therefore 9 and 3 both divide by 3. 9 divided by 3 is a 3. 3 divided by 3 is a 1. I have a 2, but there are no factors because all I have left is 1's in the denominator, so I can go ahead and multiply. 3 times 2 is 6. 1 times 1 is 1. But any number over 1 is not considered to be reduced. So the final reduced answer will just be 6. Okay, here we'll show that cancellations do not have to be adjacent to each other. So for example, in this problem involving 3 fractions, we continue the same way. We take a look at 3. There are no factors in the bottom of 3 in 10, 8, or 7. We go to the 7. Well, here is a 7 in the denominator, so these both can divide themselves. 7 divided by 7 yields a 1. And then we find the 5 in the third fraction numerator, and notice the 10 is in the first fraction. That's perfectly fine. As long as it's any numerator with any denominator common factor, you can reduce it. So in this case, 5 divides itself once. 10 divided by 5 is a 2, and then we go ahead and multiply straight across. 3 times 1 times 1 is 3. 2 times 8 is 16 times 1 is 16, and there's our final reduced answer. Cancellations can be in the same fraction, and there can be more than one cancellation in a fraction. So for example, let's look at this problem. Again, the whole number, think of it as being over 1. So the 16 is in the numerator. So you may scan this fraction and notice 8 over 12, that fraction can reduce itself. So you may say, well, 8 and 12 both have a common factor of 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. And then you notice, well, I have a factor of 3 here. And again, even though this is the result of a reduction, it is now the new denominator, so it is also subject to further reduction. So it is perfectly fine to then divide both of these by themselves. 3 divided by 3 is a 1. So we have a 16, and the only thing left in denominators are 5. 5 is not a factor of 16, so we can go ahead and multiply straight across. 16 times 2 is 32 over 5. And just to illustrate why it is so important to cancel first, let's take the same problem, and if you do not do your cancellations first and do your multiplication first, which is what students will commonly do, you've created a much more difficult problem. So ignoring cancellations, if you multiply 16 times 3 times 8, you're going to end up with 384. And 5 times 12 is 60. And then you have to reduce this big fraction. And I submit to you that that is much more work to do the multiplications and then the reduction of a big fraction than it is to take a look for common factors before you do the multiplication. When asked to multiply mixed numbers, the first step is to convert any of the fractions that are mixed numbers into improper fractions, and then you just multiply as before. So for example, if you are asked to multiply these two mixed numbers, step 1 would be to convert each of these into improper fractions. So this is a review, but 5 times 2 is 10, plus 2 is 12. So the first fraction would be 12 over 5. The second fraction, 1 times 8 is 8, plus 7 is 15 over 8. And then we just proceed as before. 5 can divide itself once. 15 can be divided by 5 3 times. The common factor of 12 and 8 that's the biggest is a 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. We then multiply. 3 times 3 is 9. 1 times 2 is 2. Now what you will see in many of the problems below where you type your answer is something like this. So you have to read this carefully. It says type a whole number. Well, 9 over 2 is not a whole number. Type a proper fraction. Well, 9 over 2 is not a proper fraction because 9 is larger than 2, or a mixed number. So therefore, if your answer is an improper fraction, you must convert it into a mixed number to get the answer correct. So as you recall, to convert an improper fraction to a mixed number, you do the division. 9 is being divided by 2. 2 can go into 9 at most 4 times. 2 times 4 is 8, with a remainder of 1. So the answer that you will type in is 4 and 1/2. In this unit, you will be given some word problems, and it's important that you recognize what constitutes multiplication. A key thing that you should look for is if you can rewrite the problem basically being asked, what is a fraction of something? The of would imply that this is going to be multiplication. So for example, here's something very intuitive that we understand. If you were asked the question, what is 1/2 of 10? We know intuitively that the answer is 5. But mathematically, how would we compute this? Well, 1/2 of 10 can be rewritten as 1/2 times 10. Remember, whole number is written over 1. And if we solve this problem by canceling the common factors, we get an answer of 5. You can see here that this is not as intuitive when asked the question, what is 2/3 of 7/10? You just don't know that answer by looking like we did above. But again, 2/3 of a fraction of something means multiply them. 2/3 times 7/10. I'll do my cancellations. I assume you know what I'm doing, since it's been covered previously. And so the answer would be 7/15. Now in a word problem, it's not going to be quite as obvious as these two examples. So here's an example of a problem from your homework. And it basically describes that a country A cost for eye surgery is $2,500 for each eye. The same surgery in country B is 4/5 of this amount. So they're asking, what is the cost of the procedure in country B? So if you look at country B, it says it's 4/5 of, so this would imply multiplication, this amount. Well, what is this amount referring to? Well, this amount is referring to 2,500. So in this case, 4/5 of multiply what? 2,500. 2,500 over 1. I will not complete this as this is a homework problem. You complete it in your homework. This section introduces the idea of computing the area of a rectangle. The formula for the area of a rectangle is length times width. So in this rectangle below, you can see that we have a width of 4 and a length of 6. Area is a measure of how many square units are contained within the object. So each of these squares is 1 foot by 1 foot, and if we were to count them and so forth, we'd end up with 24. But we don't want to do that, so the shortcut is, instead of counting the squares, is just to simply multiply. So 6 times 4 is equal to 24, and the key thing here is the units that have to go with it. This is not a linear measure. Remember, perimeter was linear, just measuring how long something is. This is a square measure. How many of these squares are contained? And so the unit would be something like square feet, or it might be something like feet squared. You'll be asked to include that unit in there. So in this case, feet squared would be the correct measure. A problem you'll have in the homework will be similar to this. Again, it's a rectangle. You're asked for the area, so you multiply the length times the width. And just, I want to highlight that you type your answer in the one box, and the other box is a drop-down box where you have to select the correct unit. Again, here you just see it written out as square miles. The last type of problem you'll be asked in this section is something like this, where you'll be asked to find both the perimeter and the area of a triangle. Now, perimeter, we already have gone over. Perimeter is the distance around the outside of the object. So be sure when you compute the perimeter of the triangle that you do not include this 66. That is not a measurement on the exterior, that is an internal measure of height. So your perimeter would be these values here. Area of a triangle is a different equation you haven't learned yet. Okay, so the area of a triangle is 1/2 times the base times the height. So the only issue here is what is the base and what is the height. So 1/2 times, now the base, notice this dotted line followed by the squared off corner. Where the dotted line hits the squared off corner, that is the base of the triangle. And so in this case, the base would be 60. I'll write it as a fraction, 60 over 1. And then the height is this dotted line that drops from one corner of the triangle down to the base. And that would be 66. And then do your cancellations and multiplication, which you will do in a homework problem. That computes or completes this section.